Welcome to the fourth video of the series. In this video we are looking at year 2017. So this is November 2017, and if you look at the questions, they are what you are expecting if you are prepared. I'll also advise you to try the paper out, this question, if you haven't. Pause the video, do the questions, time yourself as well. Give yourself maybe 30 minutes to do this question and see how many questions you will get. Now if you look at 1.1.3, it's a said equation, interesting and unique because you have a square root on both sides. But fortunately, in your practice, you should have seen each type of root and how to deal with it. Also, 1.3 is not difficult at all, but the way it's presented might confuse a few. So we start with the first question, 1.1.1. It's a quadratic equation and it is in standard form. So we factorize 7 plus 2 will give you 9. 7 times 2 will give you 14. So the signs work out and the factors work out. So x equals to -7 and x equals to -2. Moving on to the second question, which requires the use of a quadratic formula. You are given a quadratic equation in standard form. You write down your quadratic formula from the data sheet. You substitute the values, so from the quadratic equation to the quadratic formula, and you get your values there. The third question is the one that I mentioned before. So in this case, both the sets are isolated because they are on each side. That means we can square each side to get rid of the square roots. So if you square both sides, you are left with x squared minus 5 on the left. And remember, the square applies to 2 as well. So that is why we now have 4x and not 2x, because 2 squared is 4. And it's a quadratic equation, so we must get it in standard form. Then we factorize. Once we factorize, you can see -4. If you look here, -5 plus 1 will give you -4. -5 times 1 will give you -5. So x is equal to 5 or x equals to 1. But remember, you need to reject. So you go back and check, and it turns out that x equals to 1 equals to -1 is the solution, which is not working in this particular question. So, right, so we might have an issue here, but just focus on the top. There's some technical issues. So we are given these two equations. So you have 3x minus y equals to 4. That's your equation 1, your equation 2. Then you choose the simpler equation, which is equation 1. And once you've done that, what you need to do is you solve for y to form equation 3. We substitute equation 3 in the unused equation. As you can see, we've shown equation 3 as being red for clarity. So from here we simplify. So x squared plus 2x into 3x minus 4, and because we had a square here, it means we will have 2 of these. So once we've done that, then you have x squared. 2x times 3x is 6x squared. 2x times minus 4 is minus 8x. And then you multiply this as well. It becomes this. And you must be careful. That's why you have your brackets there, because you still need to multiply the negative inside. And once you've done that, we are now rushing to get standard form. From standard form, we divide by 2, negative 2, so that we can have a simpler standard form. Right, so we factorize. After factorization, we then get our x equal to 7 or x equal to 1. We then need to substitute y in equation 3. So we need to substitute x rather in equation 3. So if we do that, we get our values of y being 17 and minus 1. Quadratic inequality. So that is 1.3.1. They said we must solve for x if f of x is greater than 0. We know, because we were given in the question, that f of x is x squared plus 8x plus 16, and it's in standard form, so we can factorize. And once we factorize, we can see that our critical value is just one critical value instead of the usual 2. So because there's 1, it means our x-intercept is also a turning point. So if you look at our rough sketch here, there's only one x-intercept, there's only one root, and that is a turning point, which is x equals to minus 4. And because it says greater than, so that is above the ground. So from minus 4 to the right and from minus 4 to the left. So we can say x is less than minus 4 or x is greater than minus 4. The special question is a nature of root question. It says, for which values of p will the equation f of x equals to p have two unequal negative roots? So for two unequal negative roots, so our discriminant must be greater than 0. So our discriminant is b squared minus 4ac. Now we are given f of x equals to p. We know f of x is x squared plus 8x plus 16. And because it's quadratic, we are striving to get standard form. So we transpose the p, it becomes minus p. Now we have standard form. From here, we can get our values. A is 1, B is 8, C is 16 minus P. Because remember, P is just a number which we are going to get. So we substitute these values in the discriminant. So this is what we have. 8 squared is 16. 4 times 1 times 16 is minus 64. Minus 4 times 1 times minus p is 4p. Then we are simplifying. 16 minus 64 is minus 48. We transpose the minus 48, it becomes 48. We divide by 4, so we have p greater than 12.